Welcome to the video presentation of the one-way Anova test in SPSS. My name is Dr. Janine Allwright and I'm an instructional specialist at the Academic Skills Center. In this brief video presentation, I will show you how to run a compare means test, specifically the one-way Anova test. An Anova test is a parametric test that we can use to examine possible differences between at least 3 levels of a categorical variable for how each level scores on the dependent variable. In any compare means test, the dependent variable is scale, while the independent variable is organized at least 3 levels. If you have only 2 levels, I recommend using a t-test. I will show you how to set up the test, including the post hoc test, and how to interpret the test results. Specifically, I will evaluate the outcome of the homogeneity of variances test, also known as the Levene's test. And I will interpret the between groups p-value to assess if there are differences between the groups, and if so, if we can find exactly where those differences are with the post hoc test. I will also calculate the effect size. We will be working with the following scenario. A statistics professor is hoping to learn if his students make progress in statistics, and for that purpose, the professor measures the students' statistics skills in year 1, year 2, and year 3. The statistics skills is the dependent variable and is measured at a scale level, and the 3 years make up the 3 levels of the independent categorical variable. We will conduct a one-way Anova analysis with a Bonferroni attached to see if there are significant differences between the students in the 3 years for their statistical understanding. Let's take a look at the data set to learn how the variables are set up. As we can see here, there are 2 variables. The statistics variables represents the statistical understanding of the students and is measured at a scale level, and the year in psychology in the program is represented by year 1, year 2, and year 3 as levels in this categorical variable. We can set up the test with the Analyze button, click on Compare Means, and choose the one-way Anova option. We'll place the scale variable in the dependent box, and the students at 3 years in the factor box will ask for a Bonferroni post hoc test, and we request the descriptive statistics for the variables and the homogeneity of variance test. Click OK to run the test. Now we can see the output, and we know exactly what the mean and the standard deviation and the sample size is of each group for how they score on statistical understanding. The first step we take in our interpretation of the output is an evaluation of the test of homogeneity of variances, as I mentioned, also known as the Levene's test. This test assesses if the variances between the 3 groups of the independent variable are equal enough to be significant, and this p-value indicates that the test is fulfilled. If the p-value for Levene's is greater than 0.05, we find homogeneity of variances. Now we look to find whether there are differences between the groups of the independent variable. And the top line of our Anova table assesses that. This p-value is evaluated against 0.05, and it is smaller than 0.05, indicating that we find significance. We found differences between the groups. Now that we have found differences, we want to learn where those differences are within the groups. And since we have 3 groups, it becomes a pairwise comparison that we examine with the post hoc test results. SPSS places an asterisk next to the mean differences that are significant, and we can see here that year 1 compared to year 3 is significant, and it repeats itself. You only have to evaluate the pairwise comparisons once. Since this value is negative, we can see that the mean for year 1 was lower than year 3, or the other way around. Year 3 compared to year 1 is positive. The mean for year 3 and year 1 show a higher value for year 3, and we have 1 significant difference between all these groups. The other pairwise comparisons are not significant. The last step is for us to look at the effect size of the differences. For that, we will need to use a formula. The effect size for this Anova output is the between groups sum of squares divided by the total group of the sum of squares. And in this example, I can share with you how that comes out. The eta squared is 87.464 divided by 413.1 and equals 0.212. When we multiply that by 100, we get the percentages. We can now say that that is a strong relationship between the student's statistical understanding and the year of study in the program. The independent variable accounted for 21% of the variance of the dependent variable. This concludes this brief presentation for the one-way ANOVA. We also offer an academic guide that shows how to write the results of this one-way ANOVA up in APA format. You can find this guide at the Academic Skills Center website under the tutoring button when you click statistics, and it lives under the header APA formatting and statistical tutorials. Thank you for viewing the one-way ANOVA test in SPSS presentation.